Welcome to Getting to Know Chronicle. I'm John Stoner, a member of the adoption engineering team at Google Cloud, and today we're going to look at using aggregate functions max, min, and sum within the outcomes section in YARA-L. We're going to cover three aggregation functions that are used with integer and float fields in the outcomes section: min, max, and sum. Remember, it's important to understand that when working with multiple events in a rule, that all outcome variables that contain UDM fields must have an aggregation associated with them. The general syntax we will use is the outcome variable equals min or max or sum, followed by the UDM field or a placeholder variable inside parentheses. There are not a lot of integer or float fields in UDM compared to string fields. So where min, max, and sum really shine is when used in conjunction with conditional logic and mathematical operations. This video will focus on how we can use these aggregation functions with UDM fields, but future videos will use these functions with conditional logic and mathematical operations. So think of this as building the foundation. To demonstrate the basic application of the aggregate functions for min, max, and sum, we're going to apply them to a network-centric rule. And as a bonus, once we use these functions in our outcomes, we will demonstrate how they can be used with the condition section to trigger a detection. The rule that we're starting with is looking for normal connection events coming from Zeek that have a received byte count that is greater than 0. We are grouping them by the host name over a 30-minute window. Everything we've talked about so far is really just gathering data of a certain type. In fact, if you look at the test rule I've run against this criteria, we just have a bunch of network traffic broken up by hostname every 30 minutes. But what if we wanted to aggregate our bytes received and view those values by the sum, the max, and the minimum bytes received? We could do that by using the outcome variables. What would we be grouping the sum, the min, and the max on? The match variable over the window, in this case, hostname over 30 minutes. Let's add these three variables to our outcomes section. When we test our rule and add the fields to our view, we can see the largest, smallest, and totals at the detection level. And if we expand the detection, we can also see the values at the event level for the networked received bytes, which is the value we drew from to perform these calculations. Having some extra metrics for our analysts to see is nice, but we have a bit of an issue because of the number of the detections here are likely normal traffic. After all, these are normal Zeek connection events. But check this out. We can take outcome variables and add them to our condition section. Let's take our total bytes received outcome variable and add it to our condition section and append greater than 1 million to it. Okay, yeah, my byte values are a little on the low side here, but we are focusing on the concepts at the moment. Notice how the number of detections we have shrank. If we wanted to take another metric, like largest bytes received is less than 8,000, we could add that to our condition with another AND statement and further shrink our detections. Basically, what we have done is collect data, group it in our event and match sections, generate a set of calculations in the outcomes section, and in this case, with min, max, and sum, and then apply these calculations to our detection logic in the condition section. We didn't cover it today, but the use of the outcome variables in conditions extends beyond just an integer like we covered. But this gives you an idea of what is possible. Min, max, and sum provide additional aggregate functions that can be used in the outcomes section, but they are limited to float and integer fields. Don't forget that all event values must be aggregated in rules that contain multiple values. These aggregate functions follow a common syntax. The outcome variable equals the aggregate function, like sum, followed by parentheses with either the UDM event field with the event variable in front of it, or a placeholder variable inside of it. As we demonstrated, we can use outcome variables in our conditions to narrow our result set, but there is more to be unlocked with these three aggregate functions when used with conditional logic and mathematical operators. Which wraps this video up a bit like the end of a season cliffhanger. The good news is we will come back shortly to discuss these topics further. If you want to learn more about Chronicle, Check out my blog series called New to Chronicle for more handy tips. We have a number of community YARA-L detections at our GitHub site and are continually adding more. And don't forget to engage the security community at googlecloudcommunity.com. Thanks.